All right, we're going to graph the resulting points, I guess, that we get from these two parametric equations. Parametric equations, by the way, when we talk about graphing equations, we're typically thinking of x as an input and y as an output. And we've got our x-axis down here and our y-axis right here. And what we're changing here a little bit is we're thinking about all the points on that line, all the xy coordinates that are on that line, as being the result of some other function or pair of functions that have t as an input variable. So I'm going to take some value of t and I'm going to input it into both of these formulas, and I'm going to output an x and a y, and I'm going to plot that point. And then I'm going to take another value of t, and I'm going to input it into both of these equations, and then I'm going to output an x and a y, and I'm going to plot that point. One thing we could think of, a way we could think about this is maybe I have some sort of a particle that's moving around the coordinate plane, and we can calculate its position, x and y, at any given time for t. I think that's why we often use t as a variable for these. But it's just one way of sort of conceptualizing it. That's not actually necessarily what's going on here. But again, the procedure would be I'm just going to input values for t. I will output an x, output a y, and plot those points here on the grid. And to help keep track, I'm going to put them all in a table. So I have t, and then I have x, and then I have y. And I'm going to try, I'll put -1, 0, 1, and 2. So for my x, if I put -1 in for t, I get -3, and -3 and -1 makes -4. If I put -1 in for t here, -1 times -2 is a +2, and 3 plus 2 is 5. Okay. If you're not real good with doing that kind of math in your head, I'd recommend you just punch it into a calculator. You can just punch it in as 3 minus 2, and then in parentheses put in -1. That'll do all the work for you. 0, that's an easy one. 3 times 0 is 0, leaving us with -1. And here, let's go plot this point first. -4, 5. So that's 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's our first point right there. I'll label it -4, 5, t equals -1. Okay, plug 0 into here, and 2 times 0 is 0. 2 times 0 is 0, 3 minus 0 is 3, so it's -1, 3. Back 1, 1, 2, 3. So this would be the point -1, 3, and t equals 0. 1, so let's see, 3 times 1 is 3, minus 1 is 2, and here we have 2 times 1 is 2, 3 minus 2 is 1, so that's the point 2, 1. And let's see, that's t equals 1. For 2, see, 3 times 2 is 6, minus 1 is 5. And over here, let's see, 2 times 2 is 4, 3 minus 4 is -1. So that's 1, 2, 3, 4, 5, -1. And that's t equals 2. So in this particular case, notice our points are they're all in a straight line. And you can kind of see this because down 2 over 3, down 2 over 3, down 2 over 3. The slope is -2 over 3. So it's a straight line. Notice that there's a relationship between the slope of the line and the two equations. If you kind of take a look at it, you should be able to see it. And then when you look at your own example that you're going to do, see if that observation kind of holds with that. Let's see, were there any other questions they're supposed to? Nope. All right. there we go. Parametric equations. Again, we're just inputting a t-value into each of the two equations. We output an x and a y coordinate. We plot those coordinates. And we kind of see how our line is grown over time in a sense. So we think of this as a moving particle. We're headed kind of down. And we only tried t-values that were whole numbers, -1, 0, 1, and 2. Of course, we could try t-values in between, and presumably we would get x and y coordinates that were kind of in between, all sorts of fractions, decimals, irrational numbers, and so on. But this would be a straight line with everything filled in. It's not as though we're hopping from point to point. All right.